All right, well, welcome everybody. You have found the Hacking Sec into DevOps. We're going to use the Hacking Exposed Live style of approach to give you a little picture into the world of code security, and how hackers are using code to hack specifically and directly inside of things like the supply chain, things like open source. So I'm excited. I'm Stuart McClure. I am CEO of Quiet AI. I'm a former CEO and founder of Cylance. We sold to BlackBerry a few years ago. Before that, I was with McAfee as their global CTO. And before that, my company called Foundstone got acquired by McAfee. And I have both practitioner operator experience in the field, but I'm also a recovering developer and coder. So I actually like to still dive into it a little bit here and there, but not much anymore. I leave it to much smarter people like Chetan here with me. I'm also I'm the original founding author of the Hacking Exposed style of books, which started in 1999. If anybody knows those books, appreciate that. And we've been giving them out at the Grove, which is where we've been huddled up for the last day or two, and doing some signings. But that's been a great franchise. You know, we've covered almost every single topic as part of the Hacking Exposed style, and the Hacking Exposed style is very in your face. It's very recipe driven, very prescriptive. We believe that if you understand how the attackers really work and how easy it is to exploit everyday common problems inside of network systems, databases, now code, that you can really truly defend in a preventative way. You can stop it from ever starting, so you don't have to chase your tail and lose sleepless nights. I mean, some of you like that, I know. You get the adrenaline rush and you like to get going, but I'm getting old. I like to prevent. So with that, I'll introduce Chetan, please take it away.
Thank you, Stu. Very good afternoon to all of you. My name is Chetan Konaki, CTO and founder at Quiet.ai. My journey started as a developer, often as all of us do, and we somewhat stray into security. The reason I strayed into cybersecurity was I spent much of 2 decades building infrastructure for financial risk, high-frequency trading, and risk management. And often all of these disciplines always need to be compliant, and compliance means that you have to have some discipline in how you write code, how you deploy code. And often none of us, including me, cater to that discipline, which is why we see most attacks play out. So that's one of the reasons why I forayed into cybersecurity, and now I'm playing defense, helping analyze code, securitize code, and improve the posture.
But he has the hacker mindset, which I love, because I think that really does help everybody understand better what the problem is. So a little housekeeping on the presentation. We have I think it's about 50 minutes, I think. We want to leave a little bit for Q&A at the end if you have a couple of questions. So we'll probably end up at about 1:45, 1:50, something like that, to leave a little time. If we have time, hopefully we can get through the demos quickly and nothing fails, because it is live. So as you can maybe see on my laptop, pray to the live demo gods. Just do a little prayer for us if you could, right before we do it. But so just to tee it up, if you haven't been to a talk yet and you haven't seen the disclaimer slide, there you go. Please read every word. All right, next. All right, so the root of the problem in my book and in all the books that we've built, I've showed 2 here that we were at the Grove signing. I wrote a book called Web Hacking back in 2002. It was published in 2003. And as scary as this is about to sound, when I brought it to Chetan at the Grove to go through it one more time, and we walked through the table of contents, I would say 80% of it, 90% of it was still
relevant,
incredibly relevant today. Okay, now if that doesn't scare you, I don't know what to tell you. Like, the problems that we've known about it for 2 decades now, still incredibly prevalent in today's, not just open source, but in apps, in applications all around the world. So we are trying to elevate, I think, a little bit of the visibility here. And so I put out, I don't know if anybody has ever watched Crowder, but he has been a little controversial with his topics. So I don't really necessarily endorse the topics, but I love his style, which is, hey, I'm thinking like this, you tell me I'm wrong. Change my mind. And what we were talking about yesterday was real simple. All cyber attacks begin and end with code. Prove me wrong. And it was a fun discussion there, because a lot of people think things like, well, fraud and insider threats and all this stuff are stuff that you can't prevent in code. But I believe you absolutely can. And we did a lot at Cylance, in fact, on the persona side, on the identity side, to actually prevent a lot of those kinds of attacks, invalidating and authenticating properly. So at any rate, it can be fixed in code, either through vulnerability remediation or with design flaws, with features that are not built in properly into the application, things like this. So that's the big part of my push right now, is to get the world to see it's all right there to be prevented. We just have to know where to find it. And we have to do it with meaning and purpose. So I wanted to share that a little bit. All right, so the evolving threat landscape. When I got into the space, my history and background goes really into university, sort of around 1989, 88. I was a system administrator for a number of different systems in the computer science program, in the labs. So everybody was just, banging away and hacking things up. And sure enough, I came across, as a system administrator on one of these boxes, on the SunOS box, I came across what looked like some interesting code that had been captured. It was dump files from daemons that were running on that Sun system. And as I started to go through it, it was things like sendmail daemon dumps and finger D dumps and stuff like this. And I realized that was the Morris worm that had hit the university about 6 months before. And I was fascinated, man. It just hooked me, because I'm like, wait, how could this simple little worm run by one little person somewhere, Robert Morris, of course, now, out there in the world, take down all of these services with very little effort, if none. And to be so complex, it wasn't just like a simple 0-day or vulnerability, it was also features that they exploited to try and, that worm exploited. So I got super hooked. And then of course that went into more networking, network filtering, firewalling, things of this nature, and into system, and eventually into hardware. In fact, I did the keynote in 2012 as part of McAfee's sponsorship of RSA. And in that, did anybody see that by chance? Did anybody see that particular one? Because I think I became enemy number one on a major medical device manufacturer, because we showed up here on stage how you could take over an insulin pump and then release all of the insulin into a human body. We were not fans, I guess, of some folks, but it was really important, because we wanted to show you that software, the traditional cyber vectors can absolutely go into the physical world, and they can do it quite simply. And okay, you might ask, well, how did that hack work? Well, it worked because of a feature. So when we called the manufacturer, told them months before we were going to do this, we had this discovery, and we went through the step-by-step of what it was. They said, Stuart, that's a feature. So I said, well, your feature sucks because it kills people. If somebody can take over that 900 megahertz connection to the main pump, basically unauthenticated, it wasn't totally, but it was basically, then you could dump anything you wanted. And that was a feature designed into the function of that particular hardware device. I'm looking at good friends around here, Paul, who used to be in the ICS world. And we had the same similar situation, right? So hardware can be attacked through cyber to do things bad in the physical world. And so that talk in 2012 was, I think, a real wake-up call for a lot of folks that just had never thought about it that way. So now as we go along in our evolution in the threat landscape, I have decided everything begins and ends with code. The last place we could possibly provide the most effective preventative measures is going to be in code. So I'm super passionate and purposeful about raising awareness around, okay, how do attackers and adversaries get into code and bypass whatever controls are in there, either through the supply chain or directly or indirectly, even insider threat? How do they do all this? And why can't we prevent it? And can you prevent it with some simple techniques? So we're going to go through all of that, including a pretty cool demo we've worked up. All right, so if you look at code as that new target, and you look at the categories of attacks, you often hear things like OWASP Top 10 or CWE 25. And by the way, all these slides are available, including all the demo step slides. We're not going to go through them in this talk because Chayton's going to demo, but we have them in the main deck so you can have them detailed afterwards. But these are the basic 4 elements of vulnerabilities in code. So you have up on the top left, basically, it's API's code, but basically it's input sanitization, right? If you can control something that comes in from an attacker-controlled variable of some sort of input, then you should be able to sanitize that sucker properly so it doesn't break out of system, it doesn't pull features that you're not aware of that are built into everything that are exploited, et cetera. Second is taking advantage of actual features. Remember the feature of, yes, you can connect to the insulin pump and dump it of all its insulin? That would be in sort of what we think of as open source components or SBOM, but basically the things, the features that make up the software that's already being used by that target. Infrastructure as code, of course, and gaining access into things like the secrets that make up that infrastructure as code that have to be used constantly, any crypto that's being implemented, and allowed to bypass even weak encryption, for example. And then finally, business logic code. And we saw a lot of this actually in the web hacking book that I published way, way, way long ago, because it's simple things like changing your shopping cart item price from $1,000 to $1 and then having it process, right? It's that sort of business logic vulnerabilities that we think about hackers trying to bypass and using the features, sort of in hacking exposed style. So all 4 of these are really, that's it. I mean, pretty much every attack you see out there, every headline, every supply chain, everything, boil down to these 4 core elements. So if you can quantify these in your code, in your supply chain, all the way on through to prod, that's where you can truly prevent the attack instead of just waiting for the attacker to be caught by somebody. And so this is what we want to try and help with what we're doing. All right, did I do okay? No? Okay. All right, so how deep is this open source issue and problem? I mean, a lot of people say it's upwards of 80+% of all code that's included in applications today. And they're probably right. I mean, anywhere from 50 to 80 is what I keep hearing. Chayton knows better, but when you look at it from a hacker's mindset, you really start to fall down the rabbit hole with Alice, because there are so many places that code can go deeper and deeper and deeper into more and more libraries built in, libraries open source online, things of this nature. So Chayton, walk us through this a little bit because it tees it up nicely for what we're going to demo.
Absolutely. From the slide, we often use this cliche tip of the iceberg, but what I'm going to visually cue in the tip of the iceberg, but I'll draw an analogy of a complex adaptive system, right? If you look at ant colonies, if you typically look at a motorcycle, there are many parts associated with it, but in totality, you have emergent properties when all these parts begin to connect and provide some intrinsic value. So code is almost like that today, because code has evolved where there's much of open source that we consume. And then we take that application comprising of many libraries where we build or abstract our business logic upon, then further on package it into a container image and then deploy it into the cloud. So unfortunately, when you look at how defenders think, we tend to ossify constraints on all these systems and define this is how you're supposed to use open source. This is how you're supposed to deploy to the cloud. But that does not solve the problem, because typically in a complex adaptive system, what you see is emergent properties. An emergent property is not a property of the part, but actually a property that manifests when all these parts connect together. So if you play that analogy back on source code, we have many parts out here. So if you consume an open source library and you misuse it, when I frame misusing, It essentially means that you perhaps deploy it into a public infrastructure when the authors say don't, then someone could weaponize that situation. Or perhaps when you're using a feature in the open source library with unguarded APIs, someone could weaponize that feature as well. So all these are emergent properties, not necessarily sentient, but it's something that you do that causes this to manifest.
So gaining context within the application is really, really, really important, because you can't simply just follow the path of code and think that every step of the way you know the context under which that particular part of the code is being held, or the standards by which. So when you look at the full process of how sort of a hacker thinks and where they're going, it really does start with that unguarded API endpoint, as Chetan likes to call it. I just call it input. You know, I've got old school terminology, but that's basically the input, right? So where are the input elements inside the code? Then, well, where are the included libraries, you know, open source or privately included, et cetera, and how far do they go down? And then do they have active CVEs or inactive, or is there some campaigns associated with them? Those are all really, really important because it helps identify and prioritize. And then, of course, the vulnerabilities in the application itself. All of the things that we talked about before, these features that can be exploited, the vulnerabilities that are inside of the code itself. And then, of course, now with DevOps and being able to spin up infrastructure with a single line of code, you've got to always think about that container image with the vulnerabilities that are present natively as it's default designed and then configured. Did I do that okay? Okay.
Absolutely.
All right. All right. So with that, I'm going to turn it over to Chetan here and talk a little bit about sort of how we think about reconning that CI/CD pipeline.
Thank you, Stu. So what has fundamentally changed since the past 10 years or so? Prior to that, we used to write code, but all of that code was perhaps archived in our SCM, protected in a moat, not exposed to the public infrastructure. Then GitHub happened, then GitLab happened. So when these two technologies came to fore, we had many communities create value, we became consumers to the value, and then each of us wanted to create personal clout, which means we wanted to build our own reputation. So we tend to commit something, author something, and gather the committers. So when this played out, half or perhaps a significant portion of our code now exists in public domain. And when we deploy our applications, there are many parts to that where we author code, we consume code, and then it's passed on to the assembly line, which is our CI/CD pipeline. From there on, we run a series of checks and balances and lands up in production. So if an attacker were to think this technology change has played out, then recon fundamentally changes as well. Recon in the past was enumerating endpoints. Recon today is enumerating endpoints and also darking public domain source code to figure out ways to infiltrate your systems. So very quickly, if an attacker has to think of infiltrating into your assembly line where you write code and provide value to your customers, the first thing they're going to do is figure out ways to gain access to credentials, which means typically when you are building your SaaS infrastructure, you have a public domain www website, possibly running on WP Engine or WordPress, and then you have majority of your infra running in AWS. So often, marketing folks run point on your public domain www, which means if they commit the mistake of checking in your directory listing with your Git credentials, that can be enumerated. So here's a situation that really played out, and NCC had documented this, where a bunch of script kiddies conducted domain scan, and it so happened as a consequence, they figured out S3 bucket, then they issued a directory listing on the S3 bucket, and from there on, they gain access to the Jenkins CI credentials. And that's the first step into your assembly line. So given they landed in your assembly line, they're going to pause and situational awareness begins at this point. because there are many things that could be done. And SolarWinds is an excellent example, where they squatted for a while, assessed what to do, and figured out ways to masquerade what they're going to do so that they go undetected. So here are a few examples, quote from an excellent book, Container Security by Liz Rice. In phase of situational awareness, the first thing they look at is tamper your source code, but do it in a way where it goes undetected. The other is figure out ways to tamper your container image, if you have one, which is encapsulating your code. The other is if you're not signing your code, they perhaps could fundamentally change the shape of your code. And when it lands at your edge in your repository, from there on, it becomes a distribution center to your customers. So many things could be done in summary.
Yeah, and a great story that we had at Cylance in the early days was a major printer manufacturer had an insider that was introducing a backdoor into their core printer driver. And it was done before code signing, and no one could tell. It had been launched and released for almost a year before anyone discovered the problem. So the ability to see, to know that, hey, what you're building is actually what's getting released is a big part of the challenge and what we're trying to sort of illuminate on.
This is a phase shift, which means assume that they have no access to your CI pipelines. So how could they infiltrate your systems? One creative way to do that is figure out ways to infiltrate the open source you consume. That in itself is a very large, significantly large, unknown assembly line, where we as consumers have less awareness of. This is a very quick example where typically when a community is built around open source, most of these commercial vendors provide value to that community by letting them build or use GitHub Actions or use their CI infrastructure. And from there on, it moves into a distribution, a content distribution network, an edge, and that edge is where we as consumers consume that open source. So any of these areas can be infiltrated, where someone perhaps with malicious intent can pretend to be a committer, enter the ecosystem by possibly fixing bugs, solving little issues, gaining a reputation, getting privileges to commit, and from there on the journey begins. We've seen this play out, especially in the Node.js world, and this is progressive at this point.
So we like to say, especially as a former developer myself, I mean, I used to think very linearly, I used to think A, then B, then C, then D in the terms of code. But things have been changing, and attackers now are changing along with it. So for them, they're thinking geometrically. They're thinking about how every single condition in any section of code can be exploited, can be pushed through its own controlled input, and then ultimately break out or leverage a feature that you didn't think you wanted to allow for their own effect. So you're seeing this a lot, right?
Absolutely.
Yeah.
Absolutely.
All right, and so what we're going to try and do today, we're going to give you a little bit, and this is what a lot of the threats, all the threat adversary guys are coming after, is they're really pulling together a whole bunch of different pieces to make a whole campaign work. It's no longer something as simple as, oh, well, we're going to change the shopping cart, price anymore. There's countless layers in these campaigns. And so what we're going to show today is something a little old, something new, a little borrowed, a little blue. And that's oftentimes what the adversaries do. They take anything and everything that they can pull together to make it work. So this is a great example, little hack called Equifax. Do you want to walk through this one?
Absolutely. As Stu pointed out, this is not a new innovation from a hacking perspective. All what the attack of the adversarial entity did is chained two vulnerabilities. One, as you see on the top, which is 2017-5638, is template injection. This is a feature provided in a library called struts. It's a convenience because it enables someone to create a transformative template where you pass that data, the data is transformed to anything that's representative of value in the downstream. And given that it's a feature, you need the appropriate controls to ensure that anything as a template that's injected does not carry with it a malicious payload. And of course, we go with the whitelist, blacklist, we look at various commands, we clean up, but that song and dance has played its game. Even with remote code injection or many other cases, it's a cat and mouse chase, never ends. But here's an example of a template injection leading into a lateral movement. From there on, touching the database, and there you have your admin password, which is very common play. And from there on, exfiltration. So this is what they typically call as direct chaining between two CVEs.
All right, into the juicy stuff, into the meat. We're going to show you how we've been seeing a number of different attacks work, especially through the open source world. And we're going to pull them in together to bring a lot of the elements that we just talked about, the steps, the different chaining, et cetera, to show you how, well, quite honestly, how easy it still remains and why a lot of these attacks still work and we still see a ton of headlines. So we're going to first start off with some recon, as any good hacking exposed reader knows, right? Go do a little recon, do a little footprinting, a little enumeration. And in this case, it's code. So we're going to enumerate on code. We're going to find some juicy targets that we know we could maybe do something with and see how far we can take it to determine how far we can go. And then hopefully infiltrate and exploit and be able to do anything we want at that point, take any data, infiltrate any open AI model building pipeline, anything you want, we could do at this point. So let's hope it all works. All right, let's switch, my friend, to the demo.
So what you just saw in passing on that slide is a series of steps. So let's pretend for a moment that we are an attacker today. And we'll keep it stupid simple, because this is not a complex 0-day. This is just simple stuff. The first step, as we noticed, as we spoke of, is how can you enumerate source code? And if that source code is available in public domain, many have created value over that public domain, which is build a live index so you can actually search across that public domain.
How many have used the grep app or something else, like for index finding for functions or app? Okay, cool. Then you guys will love this.
grep app it's almost synonymous to ChatGPT's agent that's sitting and working, co-assisting you. But in this case, if you have the mindset of the attacker, you'd obviously look at CVEs, and there in the documentation, you have various methods that lead to the CVE. So one such case is an interpreter. If I show of hands, Python, Clojure, Java coders in here.
Python?
Yep. So typically in most of these data science infrastructures today, you have an embedded Python interpreter. That again is intrinsic value to the developer, where you can use the API, but also you can write a piece of code and inject that code into that ecosystem so that you can do more than just interacting with the API. It resolves that back and forth from API interaction. So let's take a quick guide as a hacker to identify all projects that are embedding Python interpreters. So as you search, you land up with varying degree of detail of various source code repositories available in the open source ecosystem that are embedding a Python interpreter. You get classic Python 3, or you get Jython in certain cases. And you can further narrow this down too, because they have ranking by repository as well, and then you can go a step down and click on Java. And often if it's Java, it's obvious by correlation or causation that it's Jython. And as you discover and search, just like an attacker would do, you want to narrow your space so that you get proactive and figure out what to do next. And obviously through this journey of searching, you'd stumble on something called as OpenRefine. OpenRefine is a fairly popular project, and popularity is again a metric on GitHub. If you examine the top right-hand side, you have 1,800 folks, 9,500 stars. So that goes to show that this is a fairly popular project. This came out of Google, and it services a particular need, which is data cleaning, missing data analysis, the first step, which is taken on before you enter into the realm of machine learning.
Yeah, so transforming data,
Absolutely.
filtering data, right?
So if you're an attacker, you land on this, grep app told us that it's embedding a Python interpreter. So the next thing you'd go to check on is how active the project is. What is the temporality of the project? So quite obvious that the origin was perhaps 7 to 8 years ago, still active because commits are rolling literally 20 hours ago. That's good news, which means that this is something that they can touch. It has intrinsic value. But before you delve into identifying whether it's exploited or not, you somewhat get a business sense. What does this OpenRefine do? It's reading from the summary. It says it's a powerful, free, open source tool for working with messy data, cleaning it and transforming it. This is the first step of ML. This is the precursor to ensuring that any data that's moving to model building is clean enough so that your model effectively iterates, error rates are effectively corrected if that model is a neural net. So critical, which means that it's possibly a part of many, many critical infrastructures. So the OpenRefine folks have been kind enough to publish a stat as well. I'm going to quickly hover down to the stats. There you go. The stats out here evidently say that it's been used in many, many infrastructures. Sorry.
Yeah, so these are some of the folks the communities that really like to use OpenRefine. You can see down here, data journalists, you see, data scientists, data enthusiasts, a lot of folks that play a lot with data, try to transform, filter, adjust, and then use that data in a programmatic way.
So the question is, why would OpenRefine embed a Python interpreter? And if you visit their docs, just like an attacker would do, because recon means understand before you progress, they speak of why they embed the Python interpreter, which is during the cleaning and transforming process of data, it could be simple as perhaps just removing spaces to actually accepting the zip code, computing the geolocation. For that, you can write a Python module and embed that Python module into your OpenRefine ecosystem, which we'll shortly see. And that's value to developers, value to consumers. But the question is, if an attacker is examining this ecosystem, they are looking at possibly weaponizing or venues to weaponize this value. So very quickly, let's switch. And like an attacker, the first step is,
we got to go back.
Oh, we got to go back. Oh, sorry, I used the word switch. Bad cue.
Yeah.
So
You're back.
I'm back. Awesome. So we read the docs. We sort of assessed why it's embedded, and let's run OpenRefine and see it. The proof is in the pudding, right? So I'm going to fire up a version of OpenRefine. And the feedback from this process is OpenRefine is a web server. It listens on a socket and provides you an API to interact with the system. And it's it can be as simple or complicated depending on the use case. There are many inputs it accepts. One of the inputs is a CSV file, and I've loaded an example CSV file. So when you click on the CSV, it gives you a tabular representation of the data that you have slurped into the system, and your next call of affirmative action is clean up that data for many reasons or transform the data to serve your machine learning needs. But from that documentation, we did glance that it's embedding a Python interpreter. So let's identify where this embedding is playing out, right? When you look at this little tab in the column and click on Edit Cells and click Transform, you land up on this UI that lets you inject a regular expression or a Python or Jython module or a Clojure module. Clojure is a Java variant, a JVM variant, sorry. It's just like Java, except functional in nature like Lisp. So all of these embeddings are providing value to the consumers of the ecosystem. So again, how can this be weaponized in creative ways? So based on this, our takeaway was we have OpenRefine, it's embedding Python, it listens on a socket. And let's go back and examine something that is pretty relevant these days, which is in a repository, given the many attacks that play out and the back and forth that happens between those that consume and the authors saying, I was hacked because of you guys. If you examine Log4j, when Log4j played out, everyone was out there picking on the open source authors, which in my opinion was not the right thing to do. But going back to the repositories of the open source, they become fairly diligent by dropping in this markdown called a security policy. So any open source you consume, try to look for this, because it's almost a telltale of two things. One is if you have an issue and you need to report a vulnerability, here's the email address or the alias that you have to go to. Somewhat gives you a sense that they're diligent about security. The second is how do you use that solution? Because open source is almost like a convenience, but that convenience could be misused in a variety of ways as well. So the authors are being very clear and prescriptive about how to use the application. So if I draw your attention to the third paragraph, I'm going to read it out loud. Keep in mind that OpenRefine is designed to locally run on users' PC. So fairly being clear that you have an interpreter embedded. So if you're going to expose that on the internet, it's going to be a cost that you have to bear because of the risk that you carry with it.
So this is their CYA, right? To say, well, just don't run it on the internet, otherwise you'll be fine, basically. Exactly. And of course, no one would dare do that, right? I mean, that would seem sort of not smart, but let's see.
So very quickly, the next action of a typical adversarial entity, shift to Shodan, search for any OpenRefine instances running in the wild. And voila, they are. There are a handful of them, which means someone forgot to pay attention to the security policy. Often happens. It's a misstep.
Or they're honeypotting us, right?
Could be honeypots as well.
Us,
But yeah, if you have to, often you have the situation where someone is conducting some journalism, some data cleaning, and they need access from their home because work from home is a new policy. They want to bypass VPNs, consequence of that.
Right.
So we have enough data now. We have something running in the open. We have a project embedding an interpreter. So the next move is, like Stuart spoken of, how would you think geometrically? Attackers don't think linearly in lists. They want to figure out ways to touch an API and then move from that API to your host, which is hosting your application. From there on, laterally move to your sensitive assets. So as a goal, someone, as an attacker, is going to strive from the outside to say, how can I touch that, embed my code into that, and from there on move to your virtual host or your physical host, which is encompassing that application. For that, we're going to again use an open source bug hunters workbench called as Yorn.
Has anybody heard of Yorn before, by the way? If you haven't, you should definitely take a look at it. It could be very helpful.
Yorn is, in simple terminology, a graph as code, which means it's going to slurp in your application, which is linear functional blocks calling each other to serve your customers' needs, convert that into a graph so that you navigate it just like an attacker would. And I have an instance of Yorn running. Yorn gives you a REPL, every time you load Yon, it lands up as a workspace in your ecosystem. If any of you have used Python, Spark, or anything which is a read eval plen true, Yon is something similar. So you can run queries on Yon. So here's my first query. We did see that a Python interpreter is embedded in the code, but we want to land to that specific location of where it's embedded. So I'm going to run this quick query. So what Yon tells me is there is code, there is a function that is receiving this functional block that can be injected from the outside as input and then evaluating that. So typically as an attacker, because most of the adversarial entities or ethical hackers use Yon, it's a very active product that's used in the ecosystem. Now they want to identify whether there is an external API endpoint that's available leading to this evaluate function that you see on the screen. Because as we spoke of, code comprises of many functions with call sequences. Function A calls function B, C, D, E, and eventually some sensitive function gets called. And if you're a diligent engineer, you're possibly validating your inputs, transforming your inputs, and in certain cases, you're not. So Yon lets you navigate that world in a creative way. So here's an example. I'm quickly typing. Give me all sources that accept parameters and expressions, which means typically if you have an HTTP server, either via GET or POST request, you accept an input. That is your source. We just saw that function on the top, that becomes the sink. So there are 2 points in the geolocation, just like your map start and end. And now you want to identify how data is flowing as taint from that source to that sink. So as I type taint, which connects source and sink, I get this very complex data flow. I apologize, it's a little
hard to read, but this is the secret sauce of Yorn and it being used not just as a bad guy, but as a good guy. I mean, to be able to take a look at your code and see all the call flows and how a lot of this, the code will work in terms of the input that's coming through it so that you can actually see, is it controlled, attacker-controlled input all the way on through?
So on a quick glance, if you were an attacker, you pay attention to get parameter. You're fetching the expression, and then you quickly identify whether there are any transformations applied. Because, when you receive input, the first thing you do is validate that input. And finally, it's going to land up in evaluate, which is the questionable function that we have, which is providing value to the customer but has issues. So it's quite evident out here there's no transformations, which means any input received is directly touching the function. So we have an issue at hand. Just to prove this out, given that we are running the OpenRefine instance, I can query for the CSRF token that's available in public domain. So all the data points are available for me to quickly query and conduct the exploit. So I'm going to spin up a Netcat listener, switch to OpenRefine. Execute a system
for those
command.
who can't see in the back a little hard, he's importing the OS library, the OS function here of os.system using or running Netcat. You could do anything you wanted, obviously. You could TFTP download, FTP download, whatever, and then run it. But he's running Netcat on the local host. And it's going to execute. If it gets a request, it'll execute a bash, a shell. If we get lucky.
If we get lucky.
There we go. Cheat sheet, always helpful.
There you go. Switch. There you go.
Okay, so
I had a Netcat listener running. I issued a command out here. This is a simple command, but many things could be done. all I'm doing is echoing back a string to the listener. And this could be a bit more complex if the intent was different. But what it proves is someone could figure out ways to essentially touch that API endpoint, enumerate it, inject a piece of code, and enter your ecosystem. So I'll shift it here, Stu, so you can just talk from here.
Yeah, there you go.
Easy.
So you can switch, Dan, you can switch, my friend. All right, so we were able to obviously take over that OpenRefine system that was running on the internet. Of course, at that point, you can do anything you want, exfiltrate data, you can laterally move. And even some of the talk these days are, well, how do you infiltrate sort of the AI pipeline? So whatever data pipeline you're using to build certain math models, machine learning models, that is a potential as you get past the initial lines of defense and can get anywhere in. But once you get onto this kind of a system, now you can take advantage of anything it's allowed in the back end. So how we fix this, obviously there's multiple sort of layers of defense that can be done here. Obviously in the OpenRefine case, follow the rules. This stuff's not built with a lot of authentication in it. It's going to be so easy to take full advantage of this stuff from the internet. If you do have to host it though on the internet, in the cloud, etc., try to apply 2FA best you can, or at least guard the APIs and the web infrastructure really well. And then of course, build those security policies properly on the systems, on the network, but also inside of the usage of that platform and that framework that we picked on OpenRefine, but it could be anything, to be honest. And look for the keys of the kingdom, which is like data transformation, data filtering functions, things like this can often expose and leave it wide open for you. So my final message, I think, both of us are, this whole industry is built on fear, right? Dominantly. And what that means is it creates this short-term pump and need for more, more tools, more people, more. And it's just not serving us well in the industry. I think we really have to think about, how do we do less with less? How do we focus on the things that matter most, that are real, that are tangible, the problems, and go fix those not just temporarily, but definitively and long-term permanently? That to me is one of my longtime passions. And where that starts is in finding the problems before they get out there. So more alerts does not mean better security. In fact, it means the opposite. We've been talking to a lot of CISOs for a long, long time, and they finally come to realize things like SIM, things like DLP, these sort of like notification systems, they don't really help us all. They are just trying to give you more alerts and more fear to keep you juiced up on having to go chase more fires. And I think as we start to pivot, transition, evolve, and look at the source of the problem, code, we can start to really impact and help all the developers and all the managers and leaders in engineering to really think securely from the very beginning. And so that's what I'm hoping that you walk away from. The ability to prioritize these findings are very, very real. And you can do it quite easily when you get the right technologies in place. So you want to wrap it up? Final words here?
Absolutely. In summary, code is the new attack vector. Fundamentally, new ways of attacking your code, but really simple ways. So you got to get your hygiene together if you decide to consume or if you decide to produce code. The other is the open source you consume, the CI/CD you build upon has become the new attack surface. So you got to watch out there as well. Fortunately, there are very many good tools available, but you got to get your necessary checks and balances in place, but also your hygiene has to go together with your checks and balances. The other is when you build a feature, keep in mind that that feature can be weaponized, or that feature that you're using from an open source perspective, when exposed, when exposed, which means you're deploying that open source in a way which was not intended, that can lead to a consequence as well. So this warrants for thinking beyond defense in depth. As Stuart pointed, fear does not sell anymore. It's sense-making of how you use these parts together.
Exactly. So all of these slides, the playbook slides, are in the original deck, so you can repeat all of these steps. You can demonstrate these to other people, sort of these techniques, to get them thinking about it, to see the potential for all of this. And thank you so much. We look forward to seeing you out there. And please let us know if we can help in any way. But we'll be around for a few minutes. So thank you very much.
Thank you.